Welcome to our presentation on the diversity and evolution of the Proboscidae family. We will be discussing a number of ancestors along the evolutionary tree, the distinguishing features that have changed over time, as well as exploring some of the family's more unusual common ancestors.
Modern elephants began evolving 40 million years ago and have since seen many dramatic changes to become the world's largest land mammal. To see the full extent of the evolutionary process, we will be focusing on three ancestors before reviewing the adaptations of both the African and Asian species.
During the late Eocene, 37 to 35 million years ago, the Meerrethium lived and dominated many North African swamps. Although the Meerrethium shares a common ancestor and belongs to the Proboscidae family, it is not directly ancestral to the modern elephant. Instead, the Meerrethium belongs to a branch of the ancestral tree that died out, leaving behind no descendants. On average, they stood at around 2.3 feet high, measured up to 8 feet in length, and could weigh up to and even above a few hundred pounds. Some features are present in both the modern elephant and the Meerrethium. For example, even though skull fossils have shown that there is no evidence indicating a large trunk in the Meerrethium, it is thought that they had a long and flexible nose relative to their body size. This could be the beginnings of the evolution of a trunk. Tusks are also a common feature between the modern elephant and the Meerrethium, although those in the latter are extremely small and are essentially the second incisors of both the upper and the lower jaws. As well as the incipient tusk, Meerrethium had 6 cheek teeth, again present on both of the upper and the lower jaw. It is fossils of these teeth that indicate their diet to be predominantly aquatic vegetation.
Living approximately 25 million years ago, Dinotherium showed distinct features of both the Proboscid family and the modern elephants we know today. 3 species branched from the Dinotherium genus. These were Bosarthi, Giganteum, and Indicum. Giganteum, as indicated by the name, was the largest of the 3 species, standing with a shoulder height of 3.5 to 4 meters. Present from the Middle Miocene to early Pleistocene, the Giganteum also had a long and flexible neck, much longer than modern elephants, for the flexibility of movement and support of a relatively small and lightweight skull. Indicum was classed as the ancient Dinotherium due to fossil records predominantly showing throughout Pakistan and India. The main feature that is unique to Dinotherium is the presence of 2 downward-facing tusks protruding from the lower jaw. Used for stripping tree bark and uprooting large amounts of vegetation, the scoop-like tusks allowed the Dinotherium to survive in its watery swamp environment before dying out during the early Pleistocene. Dentition fossils reveal that the first molar of the Dinotherium is trilophodont, has 3 grooves, whereas the other 2 molars are bilophodont, having just 2. Not only this, but the enamel layer on the Dinotherium teeth is approximately 5 to 8 millimeters thick, although enamel layers of the elephantids are thought to be thinner at around 1 to 5 millimeters. This sets the Dinotherium apart from the rest of the Proboscidean ancestors. Part of the Mamutidae family, the mastodons were approximately the same size as the modern elephant species. Remains of the first member of the Mamutidae family, thought to be a mastodon, were found in the 25 million-year-old Oligocene strata in Africa and Eurasia. Differing from the modern species of elephant, the mastodons were solidly built and hairy-bodied, allowing them to thrive in a variety of climates and ecological niches. By the late Pliocene, mastodons flourished in North America and had completely died out within Europe and Asia, leaving the genus to completely die out around 10,500 years ago during the early Holocene. Mastodons get their name from the translation of mastos, meaning nipple in Greek. Contrary to what the name suggests, this actually refers to the shape of their teeth. The tooth of a mastodon characteristically has high rounded cusps, resembling the shape of a nipple. Mastodon tusks are apparent on both the upper and lower jaw, with the upper being extremely curved, reaching up to 3 meters in length and 25 centimeters in diameter. Unlike the Dinotherium, the lower tusks of the mastodon were extremely short and could barely be seen when covered with the lower lip and trunk. One of the 2 extant elephant genera, the Loxodonta, is the largest mammal to walk this earth. The taller and heavier of today's species, the African elephant can live up to the age of 70. Modified incisors, or tusks, extend from the upper jaw and are present in both male and females, being used for a variety of functions such as fighting, digging, marking, and feeding. There are two subspecies of the Loxodonta, Africana and Cyclotis. Africana, more commonly known as the savanna or bush elephant, is the larger of the two subspecies and is found to roam the vast grassy plains. In central and southern Africa, the elephants live in nomadic herds up to and even exceeding 1,000 elephants, with females producing around 12 offspring each throughout their lifetime. The definition of the Africana subspecies is a little different to that of its ancestors, as it possesses 4 large molar teeth, each approximately 12 inches long and weighing 5 kilograms, with broad flat surfaces used for grinding vegetation. Throughout its lifetime, the Africana subspecies will replace its teeth 6 times. Slightly genetically different to the Africana, we have the other subspecies, Cyclotis. More commonly known as the forest elephant, Cyclotis shows many differences when compared to the appearance of the Africana. The tusks of Cyclotis are not only much straighter, but a lot thinner, as well as being denser than those of Africana. Furthermore, the ears of the Cyclotis are much rounder and smaller, as they do not need to expel as much heat due to their environment being more shaded. Typically inhabiting dense forest regions, such as the Congo Basin, the Cyclotis subspecies lives on average in a group size of 3, however it is possible to have larger family associations. When Europeans first went over to Africa, the number of Cyclotis elephants was estimated at being a few million. However, now there are no more than 100,000 left in the wild. Although they inhabit a large proportion of Africa, the Loxodonta is in fact extinct in Burundi, Gambia, and Mauritania.
More commonly known as the Asian elephant, Elephas maximus are the second extant member of the Elephantidae family. Some traits are shared by Loxodonta and Elephas, such as the wrinkled skin, herbivorous diet, and 24-month gestation period, but otherwise they differ quite dramatically. Body and ear size are the most obvious differences. Elephas maximus and its subspecies in Sri Lanka and Sumatra are far smaller than their African cousins, as well as having muddy brown-coloured skin rather than grey. Those of the Elephas genera also have one finger-like projection on the end of their trunk, instead of the 2 of the Loxodonta. Tusk development varies between Asian elephant males and females, with only males displaying large tusks similar to those of the African species. Female Elephas develop tushes, which do not necessarily break the skin, so are not always visible. The range of the Asian elephant once spread from the Iranian coast in the west across to eastern China, a range close to 9 million square kilometres. Nowadays, due to the ivory and leather trade, deforestation and the entertainment industry, wild Elephas maximus are far harder to come by. It is believed that the Proboscidae evolved on the African continent, so how did Elephas come to be found in Asia? The gingery brown fur, domed head and small ears associated with the Asian species are suggested to have derived from the mammoth. The Ice Age mammals were found everywhere apart from Australia and Antarctica during the Pleistocene era, migrating en masse into Eurasia 2.5 million years ago. So whilst Elephas has lost those adaptations which mammoth had to survive in the cold environments of the Ice Age, it is still believed that the Loxodonta diverged off first, leaving the Mammuthus and Elephas genus to evolve more closely.
Here we have 3 of the planet's most closely related organisms, the elephant, the hyrax and the dugong. They look a little different to say the least, so how can it be that they share a common ancestor? To understand this, we must look back at the cladogram of these animals. This is the elephant's cladogram. In the top corner, we have our modern-day elephants, Elephas and Loxodonta, which we can follow to their dividing point of the Elephantidae family. This is also the division which connects the elephants to the mammoth, and by following further down, we come to the Proboscidae, the order of mammals with trunk-like projections. Still, we have no real relationship between our 3 animals. The hyrax has a tiny nose, and the dugong doesn't even have legs. But the next step brings us to the Panungulata, the near ungulates. Evidence put forward by George Simpson in 1945 supports the existence of a common ancestor from this suborder. These species should be grouped together due to many morphological similarities. Examples include nail-bearing digits, specialised grinding molars, and incisors which have now developed into tusk-like structures. It has also been suggested that during the Cretaceous period, species on the isolated African continent developed differently to those in the rest of the world. Many factors support this theory, and our 3 distant cousins are a great example. The common ancestor from which the 3 are derived was thought to be fully terrestrial, but as ruminant mammals began to roam the plains and were able to digest the grasses more efficiently, the Afrotherian ancestor was outcompeted, so had to look for new food sources. The dugong's predecessor took to the water, exploiting the aquatic environment and evolving paddle-like front limbs to reach seagrasses deeper along the coastlines and riverbanks. Meanwhile, the hyrax moved to the rocky outcrops, where its body became smaller and developed rubbery pads and sweat glands on their feet to maintain grip on the steep surfaces. The elephant developed a trunk to accommodate their large tusks, which were useful for fighting and unearthing vegetation, but were a hindrance when it came to actually consuming their food. The trunk allows for elephants to forage for food and water while simultaneously watching out for any danger. The elephant's enormous body evolved as they were able to consume more food, and their size made them less available to predation.
30 million years ago, elephants were aquatic animals, and a shorter trunk had evolved to serve a type of snorkel function. Once submerged as the Merotherium about 37 million years ago, the trunk was an apprehensive upper lip used to grasp by wrapping its muscles around in order to adapt in the new terrestrial environment. The further step in the evolution process was the prolongation of the lower jaw in the trilithon. Large molars used to grind and chew very fibrous vegetation and materials containing cell walls, like cellulose, influenced the forming of the long jaw and spout-shaped chin. Mammoths and Asian elephants diverged from the African elephant about 4 million years ago. Although the Mammuthus primigenius reduced its jaw size, the trunk arrived to a greater extent. The upper lip was larger than the lower and had large molar teeth to provide for efficient processing of large amounts of grass. These features were a result of adaptation that allowed him to survive in the northern hemisphere and in cold environments. The upper larger lip helped the mammoth to hold more easily grip of tufts of grass while lifting them to the mouth. In the elephant we know now, the nose and upper lip extended with their muscles to form the anatomic structure the trunk has today, and not only enables the individual to reach food and water where their anti-predator adapted size makes it impossible to get to, but trunks serve also to communicate between each other or to warn their herds about threats. An African elephant has 2 fingers on the tip of its trunk, whereas the Asian elephant only has 1 finger. While the African elephant is able to grab objects, the Asian elephant can only scoop up objects with its entire trunk. In elephants, tusks are elongated, continuously growing incisors. Tissues formed in the apical opening of teeth roots enable a continuous growth and are generally curved. In elephants' tusks today descend from secondary incisors. 2/3 of the elephant's tusk is on view, whereas the remaining 1/3 is hidden and deeply embedded in the animal's head. It's a pulp cavity with numerous nerves running throughout. The visible part is made up of dentin, ivory, and a layer of enamel on the outside. As tusks never stop growing, some males show enormous exemplars. Unfortunately, it is the ivory that makes elephants' tusks so precious and the animal vulnerable. The average size of tusks decreased drastically over the past century because hunting elephants for ivory, called poaching, resulted in an increase of elephants evolving again. The natural process of evolution shows that elephants are not growing tusks anymore to adapt to their new threats.
So there we have it. From the Merotherium all the way to Loxodonta africana, proboscideans have come a long way to become the distinctive taxon that we recognize today. Thank you for listening.